Assalamu alaikum everyone. Welcome to the fourth week and 10th lecture for CS116 Object-Oriented Programming. Up to last week, we learned how to define simple classes in Python and how to instantiate objects for those classes. We also discussed some related concepts and background working for the whole scenario. Today, we'll move on to a relatively advanced concept called inheritance. So in today's session, we'll discuss basic inheritance. We'll see how we can create a parent-child relationship among classes, like programming wise. And we'll also discuss method overriding in a child class. Okay, now code reusability is one of the most favored concepts in software engineering because it saves time of the programmer. And if you are duplicating code, like if you want to do something again and again, if you are duplicating code for that purpose, that is considered a crime literally in software engineering or in coding world. We already know some ways by which we can reuse a code. One of the most basic thing is by writing functions, and we had been doing this in CP2. Then we can define classes, which we learned in the previous weeks. And once you have defined a class, anybody can use your class by simply using the interface or the public methods that are available for use, right? So the user does not have to write the whole thing again. And uh, inheritance is another way, right? Through inheritance, we can extend the functionality of the existing code without having to define that already existing code again. Okay, let's quickly recap what we studied in lecture 3. There also we discussed inheritance, but just theoretically. So inheritance, it allows a programmer to extend behavior of an existing class, right? Like we can derive a class from an existing class, and when you derive one class from another class, then the deriving class, it inherits all the attributes and methods of that class from which it is inheriting. Inheriting class is called the child class or subclass or derived class, and the class from which this child class has inherited is called the parent class or superclass or base class. Okay, then a child, it contains everything in its own class, and it also contains all the public and protected attributes and methods of its parent class. Only private attributes and methods of the parent class, they cannot be accessed by a child class. Okay, and we also saw some comprehensive example over there which shows that how we can arrange the code in layers, right? Like you can add different layers, you can define different classes in layers, and then you can arrange them in an hierarchy, and that is one of a very good organization techniques in software engineering. And we said that this is actually inheritance is a relationship. Actually, inheritance is called is a relationship. Let's first discuss types of inheritance. Basic inheritance or single inheritance means that when a child inherits from only one parent class. This is an example. We have two classes here, class A and class B. Class B is a child class and class A is the parent class, and class B has only one parent, that is class A. Okay, there is a related concept here. Inheritance could be multi-level also, like this basic inheritance, it could be multi-level inheritance also. In multi-level inheritance, the scenario is something like this. Let's suppose we have these three classes, class A, class B, and class C. Class C is inheriting from class B, and class B is inheriting from class A. We had already discussed this in lecture 3, that now class B can access all the attributes and methods defined in itself and in class A, whereas class C can access all the methods defined in itself in class B as well as in class A. So class C is inheriting directly from class B, and class C is also inheriting indirectly from class A, right? So this is multi-level inheritance. The second type of inheritance is multiple inheritance, when a single child or a single class, it inherits from more than one parent classes. And the scenario looks something like this. right? Now, for today's lecture, we won't be discussing multiple inheritance. We'll keep ourselves to only single inheritance for now. Syntax for inheritance is pretty simple in Python. We are familiar with this class keyword, then we give our class some name. Class name means some unique name for our class, and then after writing that class name, we write the name of the parent class in round parentheses, right? So you just have to add these round parentheses after class name, and you just put the name of the parent class there. Remaining structure remains the same. Then you can define attributes and methods, and while defining multiple inheritance, we just increase the list in these round parentheses like this. You can super class 1 is the first parent class, super class 2 is the second parent class, and so on, right? And then the remaining syntax remains same. Again, multiple inheritance, we'll come to this topic maybe next week. So in today's class and in next couple of class, we'll only be discussing single inheritance and its examples. Although we are discussing the syntax for implementing inheritance today, but we have been using it since the time we started defining classes in Python, because Python makes all the classes, user defined classes, inherit from this base class called object by default, right? So what does this class object offers? It offers basic functionality that any object should have. And how it does that? It provides some dunder methods. Dunder methods are actually methods which are executed at some special occasions by Python, and a child class or our user defined class, it can override those dunder methods to provide custom functionality. So unknowingly, or it's not a matter of choice. We whenever we define a user class, uh, that inherits automatically from this class object, right? But if we are inheriting it explicitly from some other class, then the scenario is different, and I'll show that to you in the upcoming slides. Okay, now let's take an example. Let's suppose I want to define two classes, animal class and a duck class. These are the name for my classes, and I'll make this duck class inherit from animal class. So let's see what the syntax should be. Okay, here I am defining my class animal, my first class animal, the base class, and I can define any attributes and method. We'll define some formal methods and attributes later in the upcoming slides. Now, let's suppose I define another class duck and I want it to inherit from class animal. So I'm putting the name of that parent class in those round parentheses, right? And then I can define attributes and method for this child class as well. Now, if I talk of this parent class, animal class, it is a child class of base class object, because it is inheriting by default from this class. So an equivalent form for writing this statement is this, right? We can write the name of that base class object in round parentheses. These two statements are equivalent. But if you are not giving any name, then also this object inheritance from this class object is there, right? Now, what about this child class duck? It is inheriting from this class animal, so it is a child of this class animal, or you can say duck is a animal or is an animal, right? What about object? Does this class duck inherits from base class object as well? The answer is yes, because here we have multi-level inheritance. This duck class, it inherits from class animal, and this animal class is inheriting from class object. So indirectly, duck class is also inheriting from this class object indirectly, right? And this is a multi-level hierarchy. Duck inherits from animal, animal inherits from object, duck inherits directly from animal, and duck inherits indirectly from object. Now let's add some attributes and methods to those two classes, animal and duck. As per our usual practice, what I'll do here is I'll start with a very basic implementation and then we'll go on adding functionality to it. So the first implementation of class animal will be somewhat similar to the one that we used in lecture 3. The same class animal, same attributes, species and language, and same method speak, right? Okay, now the first version that I'm implementing here right now, it will demonstrate this feature that a child class inherits all attributes and methods of a parent class. So we'll implement this and we'll test this trait. So let's write code for the base class first, which is animal. This is class definition class followed by class name and then colon. And we are not inheriting it explicitly from any other class, but we know that it has been inherited from that base class object. So this is the first method that I'm defining here. Now we know that this is the constructor and it is executed whenever an object is instantiated. So we can use this init method if we want to instantiate or initialize some instance variables. So here I'm taking two instance variables, species and language. Okay, and the user can pass values for these instance variable, and if the user is not passing any value for any of these or both of these attributes, then I'm setting some default values here, like species will be set to animal, like general term animal, and language will be talk. This is the second method that I'm defining here. This method will simply display this info, right? So this is a print statement that I have created. So this means that this function or this method info, it will print species colon species of that object, and then backslash n means it will come to the next line and then it will print language colon and then it will print the language. So basically we are trying to print the values of those instance variables in a specific format. Okay, this is the old method speak, and it will print the same information in a dialog form. I am a species and then I can whatever language we set for that species. So this is about the parent class. If you observe here, here we are using two instance attributes, species and language, and we have defined three methods init, info, and speak, of which init is a dunder method. That means we won't call it explicitly. It will be executed every time an object is instantiated, right? Now let's define the child class duck. Okay, for since I'm inheriting it from this class animal, so I have written that name animal in those round parentheses. For now, I am not providing any additional methods or attribute for this class duck. So I'm using a statement here, pass. I think we have not discussed it formally before, but many of you already know this. Pass means it does nothing. Because Python won't allow me to just define a class by class name, and it won't allow me to not to define any attributes and method within this class duck. So if you want to do that, you can use this keyword pass and it will just make it pass. Like, you don't have to write any formal code here. Similarly, you can use this statement with other constructs also. For example, if you are writing a loop and you just want to test something in loop initialization or increment or number of iterations, and you do not want to include any body inside that loop, then you can also use this statement over there, pass, and it will do nothing. It will just serve as a as a dummy code within that structure. This class diagram summarizes our hierarchy, our small hierarchy. Base class is called animal, and this animal class has two public attributes, species and language, and has three public methods, init, info, and speak. We are not going into that detail of making these attributes private, but you know how to do that. So if you want, you can do that by yourself. Right now, for simplicity, I'm keeping everything public. Now, duck is the child class. or the class which has inherited from class animal. I hope you remember this arrow, the direction of arrow. It shows that duck is a animal, or duck is inheriting from class animal. And for now we have not defined any explicit attributes and methods for this child class duck. Just keep in mind the difference between these two methods, info and speak. Basically both are printing some kind of info but in different formats, right? So let's write some test code now. This first statement will initialize an object of animal type. Like just forget about that child class duck. I'm right now working with the base class animal. So this statement will initialize an animal called Tom, and the values that I'm passing in the parentheses, they'll initialize the instance variables species and language. So species will be set to cat and language will be set to mew, right? Then we can print the info using this info method. It will simply print the info in this specific format, right? Okay, after this, let's call the second method speak. And as we know what this method will do, it will simply print the same information in a dialog form. I am a cat and I can mew. Now let's instantiate an object of class duck, the child class. So here's the statement. I'm initializing an object called Defi, and this Defi is of duck type, and I'm passing two parameters within parentheses, duck and quack. Now by passing these parameters, what I expect that this duck will be set as species, that instance variable is species, and quack will be set as the language, right? Now however, you note here that in this child class duck we do not have any methods or attributes defined. So what will happen, Python will first search in the current class. For Defi, duck is the current class. So first this duck class will be searched for initiator, because this line that I have just written here, this will call initiator at the back end, or you can say it will call the constructor at the back end, because we are instantiating an object. So that instantiator function will be first searched into this child class duck, because this is the current class. But since we have not defined any methods here, what will happen after failure, like after not finding that method in this class duck, Python will search it into the next parent class, which in hierarchy, which is animal in this case. So init method of animal class will be executed, and we know what that method does init in animal class. It will simply assign duck to species and it will assign quack to language. So let's test this, that it's working. For that I am calling this method info. Again, there is no method info defined in duck class. So what will happen here, it will call this method from the parent class animal. So it should print the info for this object Defi in that specific format. So species colon duck and language colon quack. Similarly, I can call this third method, and since there is no method in duck class, so this speak will be picked up from that parent class animal. So it will print this statement: I am a duck and I can quack. So this example shows that a child class inherits all the attributes and methods of its parent class, right? Now let's extend the functionality of child class. What I'll do here, I'll add some attributes and methods to the child class. So let's do that. Okay, now the base class, which is animal, it remains unchanged. So this is the code that we have already written for this base class animal. Now for this duck class, I am defining one method which will instantiate a new attribute for this class duck. Okay, that attribute is beak type. So what I'm doing here is I'm defining a method called set beak type. It is passed two argument, the essential argument self and a second argument b, and this b will be assigned to this instance variable beak type. And if the user does not provide any attribute here, then short will be assigned as the beak type by default, right? So just to summarize, because on next slide this code won't be available there, animal class remains the same. I've added only one attribute, new attribute beak type in class duck, and I have defined a method to access that attribute beak type. I can access that attribute directly also because it's a public attribute, but a formal method is that I should provide some setter method for it. So set beak type is the setter method. Okay, now the class diagram looks like this. Animal class is the same, but now we have an instance attribute, a public instance attribute, beak type in class duck, and a public method set beak type. Okay, now let's run some test code. I'll keep most of the test code same as before so that you don't find it difficult to grasp. I'll just make small changes in it. So I defined this first object Tom of animal type, so I'm doing the same here, and then I'm printing this info, and we know how it will print this info in this specific format, species colon cat and language colon mu, because these are the values that we used in initialization while instantiating Tom. Then speak, it will print the same information in a different format. Okay, now let's let's first instantiate an object of duck type. So Defi is the duck, same thing. And again, this since I have not defined any initiator function in duck, so this initialization is still calling init or init method of class animal. Okay, now I'm calling that method set beak type. Now if I call this method set beak type and I pass this value long and curved, this is the beak type for Defi. So what will happen? This value will be assigned to that instance attribute beak type of duck, right? Now let's print the info. Since we did not change this method and we did not define any custom method in duck, so this will be called from animal class again. So animal class has access to only two instance variables, species and language, and those have been printed here. So duck and quack, and speak will print this in a different format, right? So this shows that duck class can access all the attributes and methods of its base class animal, and it can have attributes and methods of its own as well. Okay, now what if I try to call this set beak type for Tom? Like, I want you to try this. Try executing this statement. What do you think this statement will do? This is Tom is of animal type. So here what I am doing, I am trying to call a method from class duck for Tom, whereas Tom is of animal type. So this should give error because when we were discussing inheritance in lecture 3, I told you there that this is a one-way pass. Like duck can access all attributes and methods of class animal, but animal cannot access attributes or methods of its child class, because the concept is that animal class or the parent class has been defined before the definition of any of its child class. So this statement should produce error, and this will actually produce error, and you can test this by yourself, right? Again, like all other previous lecture, you will find all the codes that I am discussing in this lecture in a separate code file. Okay, let's see this class hierarchy through that function directory. This is the hierarchy that we have implemented. Although we have not inherited animal from this class object explicitly, but we know that Python does that for every user defined object. So this is, sorry, every user defined class. So this is the hierarchy that we have created for now. Duck is inheriting from animal, and animal is by default inheriting from this class object. So if I run this function directory on Tom, I hope you remember that this Tom is of animal type. So let's see what it displays. Okay, this is the list of methods and attributes that will be displayed. Now, out of this whole list, we know that all these dunder methods, they are there because of that class object, because animal is inheriting from object. So animal inherits all the methods that have been defined in that class object. So these are all dunders, the white ones, they are all from class object. And the yellow ones, info, language, speak, and species, these are the attributes and animals that we define in our subclass animal, right? Info and language are the two instance attributes, and speak and species are the two methods. Sorry, info and speak are the two methods, and language and species are two instance variables. Now let's run the same function directory for Defi. So this is going to be the statement. Actually, that \n is just there to, make the output presentable. Here's the output. Now here you can see the green ones, set beak type and beak type. These are the two method and attribute respectively for class duck, right? Because these are the only two things that we define in that class duck. And since this duck is inheriting from animal, so the yellow ones, they are from class animals, and this here it is shown that these are part of that class duck because duck is inheriting from animal. So speak, species, info, language, they are coming into duck from class animal, and this class duck is also inheriting all the attributes, sorry, not attributes, the dunder methods from class object. And we did not make this class duck inherit from this class object, and neither did Python made it do that, because we were inheriting duck from animal and it was single inheritance. So duck can directly inherit from only one class, and that was animal in our case. But since animal has been derived from object, so duck it inherits all the methods from class object as well, right? And you should appreciate this fact here, that we don't have to derive duck from object. Like if you are creating an hierarchy, you do not have to, or Python does not have to derive every class from object. Only the main class, the main base class has been derived from this object, and then whichever class inherits from animal, that automatically inherits from object as well. Okay, now let's see another variation for the same hierarchy. Here, what I want to do, I want to override a method of parent class in child class. Now, if you recall from again lecture 3, overriding is a concept related to polymorphism, but this overriding is tightly coupled with inheritance. And if I make you recall what overriding means that we define a method of same name which already exists in a parent class. That means we are defining two methods having same name and same attributes, but one of them resides in the parent class and the other one resides in the child class, right? And here in this example, in this variation, I'll show you how it works. Now, the first method that I'm overriding here is speak method. Now, if you recall this speak method, what does it do in animal class? It simply prints a dialog that I am a cat and I can mew, or any species name or language. It will set that statement accordingly. So it prints a specific statement. Let's suppose that for my class duck, I want to change this method. I don't want my duck to talk like this, like I am a duck and I can quack. I want it to just quack, 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 right? Like I want to change the message in that method. So what I can do, I can define the same method in child class, and then we'll see shortly that that child class method will override the parent class method. So this definition remains same. So because I do not have much space here, so I'm just using those dot dot dot. That means the whole code remains same. I'm showing you this method speak because I'll be overriding it in the child class. Otherwise, this method is also same as before. Okay, in class duck, this is the method that I had already defined, set beak type, and this is my new method speak. Now you should notice here that the definition for this method is exactly same. The name of the two methods speak and speak in both the classes, and there is only one argument, that is that mandatory argument self. But here I am providing a different implementation. Here I am printing a different statement, right? So let's see how it will run. One more thing that I would like to mention here is that while we were studying this overriding, method overriding in lecture 3, there we discussed that method definition should be same in both the classes. Like speak in animal, it should look exactly the same as speak in class duck, and it should have the same name and it should have the same number of parameters. So many languages, they impose this condition, but Python gives you the liberty that you can change the number of parameters also. Like if I want to add a parameter in this method speak in class duck, I can do that. I can add uh, you know uh, as many parameters as I want here. This is the class diagram now, the updated one. I have added one more method speak to my child class duck. Okay, now the test code is almost the same. In fact, exactly same. Let's see what output it produces this time. Now, Tom, there is no change in animal class, so Tom will be the same. Info will print species cat, language mew, and speak will print this sentence, I am a cat and I can mew. Now for Defi, I'm defining it the same way. I'm setting the beak type, which is of no use right now. Then info will print species and language. Okay, the only difference is here. Now, since I have defined this method speak in child class duck2, so now now Python should execute this child class method speak. So here you see that this method exists in both the classes, parent class and the child class, but Defi's current class is duck. So speak from class duck will be executed. So it should print the new statement quack quack quack, and here it is. Now one thing that we noticed in our hierarchy was that we were defining an attribute beak type in class duck, and we were setting it to certain value. A user can set it using that setter method, but we were not printing it anywhere. So let's include that too in printing. I think most appropriate place where I can print it in that info method. So for that, since I cannot make that change in the base class animal, so what I can do, I can override that method info in child class, and there I can add this additional instance variable for printing. So I'll override this method info. Again, no change in this class animal. I'm showing only these this method info because I'm going to override it. So let's define this in duck class. The other methods of duck class, they remain same, set beak type, and the other one that we implemented was speak. So for info, what I'm doing, I'll print the same things that we were printing in the base class, and I'm adding this new attribute too. So this will print 3 lines: species colon the species of that object, language colon language of that object, and then beak type of that object. This is how our class diagram looks like. One more method added to class duck, which is overriding the same method of its parent class. So test code is the same. Tom is of type animal, so there is no change in the output. Again, no change in the output. Defi is defined the same way. We have not defined any init method here, so it is calling, init method of class animal. Okay, and um okay, now let's print this info. Now again, as I told you earlier, since there is a method called info in child class duck, and defi is an object of this same class, so info from class duck will be called. So it should print 3 lines. And here are those: species duck, language is quack, and beak type is long and curved. And for speak also, we have already seen it. It should print quack quack quack, and here's the output. Although this overriding is working really nicely, like this method info of class duck overrides method info of class animal, and it works the way we want it to. But there is one small thing that I want you to notice here, that we are duplicating some code. Here if you see, this red highlighted part is same in both the methods. Like this is a small example, but what point I want to highlight here is that duplicating code is not considered a good technique when it comes to software engineering. So there should be some way by which I can utilize that code that I'm already defining in the parent class in that method info, and I can simply extend that code in my overriding method info of duck class, and we can do that pretty easily, and I'll show that technique to you in the next lecture. So that's all for today. This is a quick recap. um, we discussed that inheritance is a way by which we can extend existing classes. This is a way by which you can reuse some old code. And what we do when a class inherits from another class, the inheriting class is called the child class, and the other class is called the parent class. So if there is only one child and one parent, that is called single inheritance or basic inheritance. And if there is one child and multiple parents, then it is called multiple inheritance. Okay, and when a class attributes from another class, it inherits all the attributes and method of its parent class, or of all its parent classes that lie there in the hierarchy. And a child can have some attributes and functionality of its own too. Then we saw that we can override methods uh, in a child class. Like if you want to change behavior of any method that exists in parent class, you can do that by defining the same method in child class. The condition is that name should be same. Python gives you the liberty to change number of parameters, but name of both the methods, uh, that should be same. Okay, that's it. See you next time. Thank you.